In this video, we will see how the resistors are connected in series, what will be the voltage distribution, what happens to the current, and what will be the total resistance when the resistors are connected in series. So here in this figure, you can see three resistors R1, R2 and R3. These are connected in series. That is, they are connected end to end, or even you can call it as a cascade connection. Now, these three are connected across a voltage source of V volts, and the current which is flowing through all these three resistors, it will be same. That is, it will remain constant. So here we have taken the current as I. The voltage drops across R1, R2 and R3 is V1, V2 and V3 respectively. Okay, so V1, V2, V3, these are the voltages across the resistors R1, R2 and R3 respectively. According to the characteristics of series circuit, the total voltage will be equal to the sum of the individual voltages. So we have here three resistors across which we have three voltage drops. So the total voltage will be equal to sum of these voltage drops. So V1 plus V2 plus V3, that is equal to V. Now according to Ohm's law, we know that V is equal to I into R. That will apply here across each of the resistor. We get V1 is equal to I into R1. V2 is I into R2 and V3 is I into R3. So we will be substituting these values in this equation. Now we know that V is equal to V1 plus V2 plus V3. We know the value of V1, V2 and V3. We will substitute here. V1 is I into R1, V2 is I into R2 and V3 is I into R3. So take I common here. What remains in the bracket? R1 plus R2 plus R3. So this R1 plus R2 plus R3 will take it as R equivalent, which is nothing but the total equivalent resistance or the total resistance of the circuit when the resistors are connected in series. So R equivalent is this. R eq is nothing but the equivalent resistance, and it is given by R1 plus R2 plus R3 because we have used three resistors. So we have written it as R1 plus R2 plus R3. So from this equation, what you will get to know? Here the total resistance of the series circuit, it is nothing but the arithmetic sum of the resistances connected in series. So if you have n number of resistors or the resistances which are connected in series, then you can write it as R is equal to R1 plus R2 plus R3 and so on up to Rn. Okay. So when you connect any resistors in series, the equivalent resistance will be the arithmetic sum of the resistances which are connected in series.